Alright, this is lesson 31 for 8th grade, and today's topic is adding integers and collecting like terms. My little sub note here. This is very important stuff. This is going to help us out in algebra, definitely. Big rules here that we need to try to remember and get used to. We're going to go through this fairly quick on the video, but in class we'll be splitting this up into 2 sections, probably 2 to 3 days, just to make sure we get this stuff down. Alright, so we need to recall that integers include the counting numbers and all the opposites of the counting numbers, which would be -3, -2, -1. So those are the opposites of these ones. And they also include 0. So we're going to show examples of how to add integers today. And if we look at, we definitely see integers on thermometers. So if we look at a thermometer, we know, especially living in Minnesota, we can get down to some pretty nasty temperatures in the negative degrees. So positive numbers would indicate above freezing on the Celsius scale anyway, and below 0 would be all of our negative degrees. That'd be below freezing. Alright, so some life applications here. We'll just look at these real quick. If the temperature in the morning is -4 degrees, but increases to 10 degrees by noon, what is the noontime temperature? Well, that would leave us with -4 and going up 10 degrees. This is basically saying the same thing as 10 minus 4. Positive 10 minus 4, but -4 and going up 10 would leave you at positive 6 degrees at noon. And we're going to get into how to solve that. Here's one, like if you owe somebody money. So Sam has no money and owes a friend $5. If Sam earns $15 washing cars, then he can repay his friend and have money left over. So that's to write an equation for this situation and find out how much money Sam has after he repays his friend. Alright, so when Sam has no money but owes a friend $5, that means he's -$5. He's in debt $5. So -5. But if he earns $15, that means he's up $15. But he has to pay his friend that $5. So after he's done washing cars and repaying his friend, Sam would be left with $10 after that. Okay? So these are some applications where we would use integers and adding them in real life. Okay? This just shows us how we can show adding integers on the number line. So here we have -3 plus 5. So anytime we have arrows to the left, that means we're going in the negative direction. Anytime we have arrows to the right, we're going in the positive direction. So this tells us, and we're always starting at 0. 0 is our origin. So we always start there. So from 0, this problem tells us to go -3, or to the left 3. So that's what they did here. They went 1, 2, 3 to the left. And from there, we're going to go +5. We're going to add on +5. So here would be 1, 2, 3, 4, 5. And that leaves us at 2. So -3 plus +5 gives us a +2. Okay? Now this one's a little different. This one we start at 0. And it says, okay, go on the 3 in the positive direction. So we'll go 1, 2, 3 plus -5. So we're going to go 5 in the negative direction. 1, 2, 3, 4, 5. And we find ourselves at -2. So +3 plus a -5 results in -2. Okay? So we could always do these on the number line, but obviously when we get into some bigger numbers, that's going to be an issue. Okay, here's one of the last ones we'll do on the number line. Remember, we start at 0, and our first direction says we're going to go -5. So we're going to go 1, 2, 3, 4, 5. So we're at negative 5, but then we're adding on negative 3. Basically means we're going even more negative. So we went negative 5 plus negative 3, so we're going 3 more negative. 1, 2, 3. That leaves us at negative 8 for an answer. So let's just take a look at what we found with those 3 examples. We found out that negative 3 plus a positive 5 resulted in positive 2. Positive 3 plus negative 5 gave us a negative 2. And when we added 2 negatives, we ended up getting a negative. So, when we added, so when we add a negative and a positive, we can get a positive or a negative answer. It depends on which number gets that negative in the first place. So, here, negative 3, well, let's just look at 3 and 5 without the symbols. 5 is bigger than 3, so this basically says 5 minus 3 if you think about it the other way. So 5 is the bigger number. If the bigger number has the negative, like in this one, you're going to get a negative answer. If the smaller number has a negative attached to it, you're going to get a positive answer. So this is more positive than this is more negative, and this is less positive than this is more negative. So basically just remember that if the bigger number has a negative attached to it, when adding, you're going to get a negative. If the smaller number has a negative when adding, you're going to get a positive. And then when you add 2 negatives together, you're always going to get a negative. So let's take a look at some of these. Alright, so it tells us to find each sum. And remember, this is the very beginning of all this. We'll be getting more comfortable with this as the year goes. So here we have negative 6 plus positive 2. Alright. So without using the number line, let's try to think about this. Our bigger number, 6, has a negative. So we know we're going to get a negative answer. Because we have the bigger number is a negative, and we have a negative and a positive. So we will get a negative answer. So really this says, okay, we're at negative 6 degrees, and then we're going to go up 2, okay? So that means we're going to go up to negative 4 degrees. Finding A is basically doing this. 6 minus 2, we get 4. And we have to remember that we're going to get a negative because the bigger number was negative. So we'll just attach that negative to it, okay? We can do the same thing for B. We have a positive and a negative, but the bigger number is positive than the smaller number, okay? So the bigger number is positive, we're going to get a positive answer. You don't need to write the plus sign. A positive answer just comes out. You could just leave it as just a regular number, but we will get a positive answer here. So this one says 6 minus 2, but we know we're getting a positive, so this one's just 4. Okay? Now remember our rule for C, we have a negative plus a negative. That means we're going to get a negative. Alright? One thing we can do for this one, just, if we want to think about it, let's say we're at negative 6 degrees, and then it goes down even more negative, negative 2 degrees. We will get negative 8 here. What we could do is do 6 plus 2 and get 8, and then just remember that our rule says we'll get a negative answer. So we could do it that way. Our last one, negative 6 plus a positive 6. Okay? Neither number is bigger when we don't look at the signs. 6 and 6 are the same number. So a negative same number plus a positive same number cancels out, and you're just left at 0. That's like saying we started off the day at negative 6 degrees, and we went up 6 degrees, so we are now at 0 degrees. I'm going to check my time quick here. Alright, we're doing okay. And I understand that this may be a little confusing at first, but we're going to spend quite a bit of time on it. Alright, this just shows what I was showing you before. 6 minus 2 is 4, and 6 plus negative 2 is also 4. So this says subtract 2 from 6 or add negative 2 to 6. Technically, I guess I didn't show you that, but this subtraction is the same as positive 6 plus a negative 2. So what we got for this one, this is basically saying 6 minus 2. This is another way you could write it. We'll get into that more with our notation. But if you're not sure if this really works out, do these on the number line. You should get the same answer. Okay. Now, along with this adding and with integers comes collecting like terms. What we would say with like terms, well, before we get into that, I guess we should introduce what a term is. A term is an expression that includes a positive or a negative number and may include one or more variables. So here are some examples of terms. 3y is a term. X is a term. Negative w to the second is a term. 3x squared y is a term, where all this is being multiplied. 3 and y are being multiplied here. Negative 2 is a term. Okay? And it says the number part of a term is called a numerical coefficient, or just a coefficient for short. We call those coefficients. So they take each of these and they show us what the coefficient would be. Big words, nothing to be afraid of though. So the coefficient of 3 times y, or 3y, is positive 3. It's not negative, so that means it's positive, and the number in front of it is 3. The coefficient of x is positive because it's not negative, doesn't have one of these, so it's positive 1. If you don't see a number there, that means 1 is there, because remember 1 times anything is itself anyway. Okay? So that means the coefficient for negative w to the second will be negative 1. We know it's negative because there's a minus sign in front of it, and we don't see a number. Alright, the coefficient of 3x squared y is positive 3. There's the number 3. There's not a negative in front of it or a minus sign, so we say 3. And to notice that if the coefficient is 1, or we do, as I pointed out, the coefficient is 1 if it is not written, so it is understood to be 1. And a term without a variable, such as negative 2, we call that a constant. So this has no coefficient to it, we just call that a constant. Constants are nice, they are just numbers. Alright, so if we want to do, let me check my time quick here. We're getting there, about 2 minutes left. Alright, if we just want to identify the numerical coefficient of these terms, we would look at what number is in front of each of these and what sign is in front of these. So for A here, we don't see a number. So remember, if we don't see one, it's 1. And I don't see a minus sign or a negative sign, so I know it's positive 1. You don't have to write positive 1, you could just write 1. Alright, B. What's our numerical coefficient there? Well, I don't see a minus sign, so we know it's going to be positive. And the number is 3, so your coefficient is 3. Alright, now C. I know it's going to be negative because I see that minus sign or the negative sign. I don't see a number, that means we're at negative 1 for a coefficient. Now, identifying those coefficients will come in handy because what we're going to do is combine like terms. That's what we're getting into. So, we can identify like terms by looking at the variables. So that's the key, the variables. Like terms have identical variable parts, including exponents. So the variables may appear in any order, doesn't matter. So these would be like terms, negative 5xy and yx, because these contain the same variables. What I like to do is change the order around, so negative xy and xy, I would say. I'm going to check my time again quick, sorry. Alright, I'm going to turn this into 2 parts. We'll come back to this slide and show you a couple examples once we get back. So stay tuned for part 2.